On the bench today we have a old 23 channel mobile radio. Nothing, super fantastically special, but nice little old rig nonetheless. It's a Pearce Simpson. Used to be actually a popular brand back in the day. They were also popular overseas. I know some country, I think Australia, I think it is, or maybe it's New Zealand, one of those countries. That was, I guess, a really big brand in one of the other countries. But they were actually fairly popular in the United States. Had boatloads, actually dozens of different models of radios they had released back in the day. But unfortunately, like most of the CB manufacturers back in the the CB boom days, that's one of the companies that unfortunately went bye-bye at the end of the CB boom, thanks to the cell phone and more modern devices. But a customer that bought this one, he had one of these back in the 70s. Not this radio, he just recently got this, but he had one of these back in the 70s. Bought one new, loved it, great talking radio, and just wanted to turn that off. I was starting to break squelch there. And just wanted to get another one, restored a lot of radios for him. He just wanted another one of these, because he had one, he really liked it. Now it is a 23 channel radio, but absolutely nothing wrong with that. Around here, this radio do you just fine. Now, you get to the local channels, channel 19, especially if you just want one to stick in a vehicle to talk to the truckers. You only need actually a one-channel radio, 19. But this may say Pearce Simpson on the outside, but if you look on the inside, it's extremely obvious who made the radio. You can see the transformer right here. Uniden. So yes, very, very clear who made the radio. Back in the day, the large majority, not all, but the large majority of the radios back in the day were made by either Uniden or Cybernet. Basically, the faceplate that was on the radio, the manufacturers had that, but the guts of the radios were either Uniden or Cybernet. Both of them made excellent chassis. And this is a good little radio. Like I say, it's 23 channels, so this uses crystal mixing. So it has 4 transmit crystals and the line of, I'd have to look at the schematic or count them down in there. I can't even remember how many receive oscillator. Once I got 1, 2, 3, 4, 5, 6 receive oscillator crystals. And 4. Or actually the mix. Okay, there's 6. Synthesizer oscillator. So 1, 2, 3, 4, 5, 6. And then you have 4, which are actually, there's 4 receive oscillator, 4 transmit oscillator, and then there's 6 synthesizer oscillator. So what they do is either 4 receive crystals, one of those 4 will get mixed with the synthesizer oscillator crystal, or if you're transmitting, one of the 4 transmit crystals will get mixed with one of the 6 synthesizer oscillator crystals. So I mean, they're nice radios. They work well. It receives fine, transmits fine, has good power. Only thing, it worked when he sent it to me. Now the inside was very dusty, so it looked like it had probably been in a vehicle at some point in its life. Had a layer of dust and dirt on the other side of the circuit board, which would normally face up when the radio's mounted. Just dirt that got in between the covers. But it worked. So, basically needed to replace the electrolytic capacitors, do a transceiver alignment to it, good cleaning. I still have to do the bezel, take all the knobs off, clean the faceplate up really good. The covers the covers are in nice condition. You can see, one little nick right there, but otherwise, covers are really nice shape on this thing. And you can often pick up radios like this for next to nothing. People think, this old radio, what the hell use is that? That's not worth anything. If you're trying to get bukus of extra channels, this ain't the radio for you. If you want sideband, obviously this isn't a radio for you because it's AM only. If you want to get above channel 23, again, not the radio for you. Now don't get me wrong, you could use a VFO, you could install different crystals in here, actually to come up with any receive and transmit frequencies that you want, but you're going to lose, a bank of channels between 1 to 23 by doing stuff like that. But you just want a cheap little radio to get on the, like emergency use in a vehicle, so you can get on 19 or just monitor, road traffic conditions. hey man, a radio like this is perfect. You can often pick them up for next to nothing. Shoot, you can a lot of times find radios like this new in the box still. You'll still need to change the electrolytic caps, especially if it's brand new and has never been used, because that's actually very hard on electrolytic capacitors, never using them. That's actually one of the worst things you can do to an electrolytic capacitor, is basically stick it on a shelf and never use it. It will die faster than one that's in something that gets used occasionally. That actually helps every time you turn it on, it helps to reform the capacitor a little bit. But other than that, they're great radios. Like I say, good chassis, unit in chassis. No fancy features. Well, actually, I guess it does, because there are smaller radios with a lot less features. So, dual control volume squelch. It does have a mic gain. Does not have an RF gain, which honestly, to me, is fine, because I never use RF gains. It just stays turned up the whole way all the time. Tone control, which actually I like. Tone control actually works very well as an additional noise filter for me. That's the way I use tone controls in practical use. I don't use it to actually adjust the tone for my hearing pleasure. I use it to block out the high, because most of your static noise is going to be actually, if we turn it on, turn the squelch down. So there, you can hear that's hiss. I can get rid of all that, a large majority of the hash and the trash with the tone control. And just get to that right at the edge of it, like right there. So I'm still getting some highs, but it's blocked out a large majority of it. So that's really nice. Now this has a receivo slide. You can see that there. Okay. It's a delta tune, some people would call it. It's, clarifier, but it's not a full rotation. Most of your radios back in the day had, like this one, they have a 3-position switch, okay? So middle, because you have to remember, this is not a PLL synthesized. It's not a solid state synthesized radio. It uses crystal mixing. So, and there's no adjustment for these crystals. These crystals oscillate at whatever frequency they're at, and you're just kind of stuck with whatever it transmits on and whatever frequency it receives on. That those frequencies, when they're mixed together, whatever they come up with, you're just stuck with it. If the crystal goes out of tolerance, yeah, now if this was a sideband radio, yes, each one of those crystals, and if you've ever worked on early crystal synthesized sideband radios, you'll find that every single crystal will have a trimmer capacitor off of each one. You really don't need that in an AM radio, because you can be off by hundreds of hertz, honestly. In an AM-only radio, you'll never notice a difference. Now, once you get, kilohertz or more off, yes, it becomes definitely obvious. But you can be off a significant amount on an AM radio, you'll never notice a performance difference. But, if the crystals start to get rather far out and receive, that's what the receivo slide is for. So you can either drop down or up a little bit. And all that does is I'm not sure if they use inductors or just capacitors in this radio. We'll just take a peek at the schematic really quick. And okay, so actually they use a capacitor in parallel with that line for, that would be the minus, and on the positive they actually add a little bit of inductance and some resistance. So actually it's kind of out of view here. It's actually this circuit right here. There's the switch. So here's the receive oscillator. Here's your crystals. So you have the crystals. They can go through 3 different paths. So the receive oscillator crystals are over here, kind of falling off. Just move the camera a little bit more, get it all in view. So you've got your 4 receive crystals. There's part of the wafer switch. The center right here, 10 ohms, would come over to the receive oscillator. If you want to reduce the frequency, the receive frequency, you'd flip the switch, that knob right there, to the minus mark, and that adds a, what do we have there? 80 picofarad capacitor in series. So instead of going through that resistor, it goes through that capacitor. And if you want to increase the receive oscillator frequency, you can see they add an inductor and an 18 ohm resistor here. So that's all they do. It's just a capacitor or a resistor and a inductor in series to the base of the receive oscillator. But like I say, kind of needed on this style radio. You can tell definitely how early this thing is. As far as solid state radios go. Look at the board number. Yeah, it's a Uniden PC001. Yeah, this is like, I guess, the first, possibly, it doesn't, I don't know, Sam's came out in 75. It may be the first Uniden board, possibly. I'd almost have to do a little bit of research on that, but yeah, I'm sure they had some other numbers, PAs and PBs, but PC is the most popular line for Uniden chassis boards. So this might be a really, really early one. But otherwise, fairly common components in here, other than there is a thermistor. That's one thing you actually find in a lot of the old rigs. They might have 1, 2, or 3 thermistors in them, and this is no exception. You can see TH1, that little guy right there. But otherwise, components are pretty much still the same as your modern 40-channel radio. Now, the only thing it looks like this radio had ever had done to it at one point in its life, somebody let the smoke out of it. I think they probably hooked the power cord up backwards. Very common. I don't know how in the hell people do that. Red's positive, black's negative. You'd think everybody knows that, but people still do it. The trace was burned off right here, and someone had repaired it, so it's actually burned under there. They just put a piece of jumper wire there, and that's fine. The trace has been repaired. It's not like that's, an RF-sensitive area, so, that works just fine. But and you can also see that the inductor right here that's on the power line, I don't know how well that'd show up on the camera, but it's actually, you can see it's discolored towards the top because it got really hot. And there's no reason to change that. It's still fine. It's just a piece of copper wire. But, yeah, you can see it did get hot. It started to burn the enamel coating just a tiny bit. It started to bubble a little bit, but it's still coated. It didn't actually cook through to where it's now bare wire. But, yeah, so somebody, I guess, hooked up the power cord backwards one day, because it looks like that's the only component that was ever changed on here was this diode. So they replaced a reverse protection diode, because that's what happens. It goes dead short, and goes up in smoke a lot of times. And also, as in the case of this radio, takes a circuit trace with it. But, once that opens up, then it protects the rest of the radio. So, but there you go. There's just a really quick view of like I say, Pearce Simpson Tiger 23C. Nice old radio. Still works great. Receives and transmits fine. Crystals are actually fairly close on frequency. Like I say, absolutely no adjustments in this radio for that. It is what it is. But there you go. So now I can send this back to the customer, and he can have a radio just like he used to use back in the early 70s.